In today's video, we will be exploring our athlete profile generator Dial application. The output is a generated PDF report about our player of choice. Let's dive in and take a look at how we get there. We'll start by asking the application what it can do. It explains to us that the profile generator consists of several distinct agents, each specializing in a specific task. Some of them rely on generic LLM calls with a bit of prompt engineering under the hood. For example, the general questions agent can attempt to answer basic questions or generate some themed jokes, while others leverage code generation and deterministic statistic retrieval to provide interesting analytics or visualizations. Dial's unified API allows developers to create multimodal applications and provides a framework for weaving these agents together into a single access point for the end user. All Dial applications are also accessible programmatically via API. Let's ask for a complete profile for Mookie Betts so we can see each of these agents in action step by step. The first step of the process is calling the Dial WebRag agent with a special prompt to retrieve the latest news about Mookie Betts. Dial WebRag searches the web and summarizes the most recent relevant updates. In this case, it tells us that Mookie has recently returned from injury after a 2-month IL stint. It also tells us exactly which articles and news sources it used for its text summarization. Next, we call our simple general question agent and ask it for some jokes about Mookie. While these jokes probably won't be making it to any stand-up comedy specials anytime soon, nor do all of them even make any sense, we included them in the summary as a mini demonstration of potential sources of creativity that generative AI can inspire. All kidding aside, we move on to the next stage of the profile, getting the biography. Similar to the latest news, this calls Dial WebRag with a prompt to retrieve his biography and returns it in text form, along with links for further exploration. Now, let's take a look at some more technically complex agents. In this case, as Mookie is a hitter, we ask it to generate a heat map of the strike zone and quantify how he has performed at handling pitches in each region. To do this, we ask the LLM to generate Python code to process the data and visualize it using the Plotly library. This is one of the more important differentiators between writing a custom application or agent and calling a language model directly. Within the custom application, we can deterministically control exactly how the data retrieval is done and exactly what prompts and context we send the models to get the desired output. We can validate it step by step. In this case, we ask the language model to generate Python code to create this heat map based on the statistics we have about Mookie's slugging percentage per pitch, based on the pitch's location. We don't need to assume that the underlying statistics are correct. In this example, we rely on some sample data, but in production, we can retrieve it from Sportradar or any sports stats API of choice. This approach, the fusion of determinism and generative AI in specialized agents, allows us to have validatable and verifiable steps. Now, within the summary generator, we will feed this heat map back to the Vision AI model for interpretation and analysis. Of course, here we lose a layer of this determinism as we are asking an AI for its input, but at least we can fully control both the content and the context that is sent to it as we generate the image programmatically. Another example of this deterministic style AI agent is our recent performance analyzer agent. It's no secret that right now, at least at the time of this video's release, large language models are not very reliable at solving math problems or performing arithmetic. However, they are very good at understanding the problem and generating code to do this arithmetic. Here's an example. This agent takes as input some game logs. I'll re-emphasize that this retrieval stage is deterministic, and call APIs or feed it validated files directly and ensure that the data being used is correct. Next, it generates the Python code to break this data up into last week, last 2 weeks, last month, and the whole season. These are arbitrary date selections. Of course, we could ask the application to filter the data however we want. Next, we define the statistics we want: total games the player played in that time period, average runs, homers, batting average, OBP, slugging, you name it. This Python code calculates the requested statistics and outputs them into a table, which we can ask our interpretation agent to analyze and see if it can find any interesting trends. Now that we've finished our dive under the hood, let's take a look at the output files that our application generated. We can see the generated visuals and tables, as well as the raw data that was used. But most interestingly, we can take a look at our generated PDF. It aggregates all of the data that the agents have produced and presents it in a digestible format, including all of the calculated statistics and generated visualizations, as well as some insights and interpretations of this generated data. Let's take a quick look at the heat map evaluation from our report and compare it to the output of a generic language model with no additional context. Here's what the LLM, not our application, just direct communication with the model, told me when I fed it Tarek Skubel's batting average against heat map with no additional context. For starters, it failed to identify that it's a heat map for a pitcher, even though it explicitly mentions it's a batting average against chart and mentions Tarek Skubel, one of the best pitchers in the league and frontrunner for 2024 AL Cy Young Award, by name. You can go on and on about the shortcomings, but I think the point has been made. It's not about criticizing LLMs and their performance. It's about illustrating what can be done by adding a level of determinism into the LLM equation by creating purpose-built agents for specific tasks. Agents that understand the context and meaning of the data they are working with and can control exactly what gets sent to the LLMs. All of this is facilitated by AI Dial's API-first approach supporting multimodal models and applications, as well as our Talk to Your Data framework for quickly developing this and other agent-driven AI applications. Thank you.